Hello, in this video we're going to define power, which is in some ways a convenience quantity. Power is what lets you tell the difference between pushing a box along the floor in a second and pushing the same box over the course of a minute. Things are different there, even though both cases could very well have the same amount of work being done. Power tells you how quickly the work is done. It's the rate that work is done. So our definition is simply the time derivative of work. That would be the instantaneous power. Frequently, what's more handy is the average power. So if you have some delta work over delta time, because the instantaneous power, that could go up and could go down, and that might actually be less useful than an average. So to go back to the example of someone pushing a block along the ground. So there's a person whose arms come out of their neck and they're pushing this block along the ground, and they could do it quickly or they could do it slowly, or they could change the rate that they're doing it. Maybe they give it a nice good push at the beginning and then they kind of get tired. In which case the instantaneous power would be some function of time, but the average power is just a number. And that can actually be handier. A lot of devices tell you the average power, even though the instantaneous could be bigger or less. Regardless, for either of these, the units are going to be units of power divided by units of time, so joules per second, which is equal to watts. So we use W for watt, not for work. That's kind of an unfortunate coincidence here, but W for watt. These are the very same watts that you see printed on the top of light bulbs, for example. So that's how much energy per time the light bulb uses to make light. We can also invert this definition. We can say that 1 joule is equal to 1 watt second. Okay, usually don't talk so much about watt seconds, but maybe you talk about kilowatt hours. You may have heard that term before. If you have to pay a power bill, that's what they're charging you for. The power company, as it turns out, does not actually sell you power. They sell you kilowatt hours. And what is one of those? Well, this is just a unit conversion problem, but it's I don't know, just to give you a sense of these numbers. So you take a kilowatt, multiply it by an hour. A kilowatt is equal to 1,000 watts, that's the kilo, and you multiply it by an hour, which is 3,600 seconds. And so a kilowatt hour is 3.6 times 10 to the 6, 1, 2, 3, 4, 5, 6 joules. So 3.6 times 10 to the 6 watt seconds, or joules, which is 3.6 megajoules. A kilowatt hour is 3.6 megajoules, and that costs a few cents from the power company, who actually sells you energy or work. They're an energy or work company, not a power company. There's another way we can look at power. Let's put that on a clean slide. You could say it's another definition, or it's just another version of the same definition. So power is the time derivative of work with respect to time. So that's the time derivative of work. Time derivative of work is force times displacement. We'll just say x for displacement, times cosine phi. Don't mistake this for a cross product. That's a variable x. And let's make the assumption that the force is constant with respect to time. Not necessarily constant with respect to position, but constant with respect to time. In that case, it comes outside of the time derivative, and power is equal to force times the derivative of x with respect to time, and then we have this cosine phi, which shouldn't be a function of time. Let's just say it isn't. We'll say that's part of force being constant. In which case we get force times velocity times the cosine of the angle in between them, which we could write instead as a dot product. So another way to write down power is the dot product between force and velocity. Instead of the, as a reminder, we'll put that over here. Reminder, work was the dot product between force and displacement, take the time derivative of that, and you get velocity. So really not such a surprising thing.